Saunders Chem, this is Ms. Brucker. I thought I would give you a video on um, the Chatelier lab and um, talk you through some of these things. And I want to commend you all. You guys are doing a great job with this. This is not easy stuff to do on your own. So I've been looking through your labs and you've been doing great. So I thought I would just kind of go through each example and talk about one or two of them that you really don't need to worry about, and you don't need to focus too much about it going forward. So the first system here is the cobalt one. It is blue and then red on the product side. Please notice that the observation before is that it was purple. So whenever you see a mixture of those two colors, that means you have both species in there at equilibrium. So I put essentially what I thought the color was at the end of the experiment, and then it's shifting left or right. So if I'm increasing the temperature, the heat is on the product side. This is an exothermic reaction, so that means it's going to shift it to the reactant side. Likewise, if I decrease the temperature, I'm removing heat from the product side. So the way I give as the thought process is that I'm digging a hole on this side. So I want to remove it. I'm removing it from the product side, so it's going to try to fill up that hole again. So it's going to shift to that side. I'm adding water in the next experiment. That's adding a reactant, so it's going to shift to the opposite side. KCl, realize that KCl breaks up into K plus and Cl minus. So Cl minus is on the product side. So I'm adding product, so it's going to shift left to the reactant side. And then this last one, the silver nitrate. The silver nitrate breaks up into Ag plus. Well, Ag plus actually reacts with Cl minus to make a precipitate. You don't need to know that, but if you go further in chemistry, it's a pretty major precipitate that you do see. So I'm removing Cl from the equilibrium. So if I'm moving Cl, that's the product side digging a hole. I'm going to try to make that up. So I'm going to shift it to that side. So I will not give you an example like this, but do note I might give you some hints of removing Cl by adding Ag plus or something like that. But you do not need to know the chemistry behind that. Iron thiocyanate. Again, I thought it started as a light orange, which is a yellow-red mixture. And then I saw the change in color, and then it's shifting. So case SCN is actually SCN minus in this equilibrium. So I'm adding a reactant, so it's shifting to the product side. FeNO33 is actually Fe3 plus. I'm adding a reactant, so I'm shifting it to the product side. If I'm increasing the temperature, again, this is an exothermic process. I'm adding heat to that product side, so it's going to shift it to the opposite side. And then Na2HPO4, again, you don't need to know this chemistry. HPO4 removes Fe3 plus, and it fills up it tries to fill up the hole, so it shifts to the reactant side. Then the chromate system here, I have a yellow and a red, so it's starting more of an orange. If I'm adding HCl, I'm adding H plus. Again, there's some acid-base chemistry we didn't get to this year. So please note that H plus is an acid. So I'm adding H plus to this equilibrium, so it's going to shift to the product side. NaOH, OH is a component of what we call a base. So if I'm adding OH, it's going to react with the H plus and remove it. That's really the chemistry behind it. But another way you could think about it is H plus OH makes water. Okay, so if I make water, upper water is on the product side, it's going to shift it to the opposite side. And then this last one was one we found that had gases involved. This is a pretty famous equilibrium between N2O4 and NO2. I'm thinking it's more of an orangey color, and I know that in the video he talks about it turns a light orange when you increase the pressure, when he pushed in the plunger essentially. And so it is every time you increase the pressure on an equilibrium, look at how many moles of gas you have on either side. I have 1 mole on the left and I have 2 moles on the right. So if I increase the pressure, I'm going to go to the side with less moles. That is to alleviate that increase in pressure. So it's going to shift it left. If I increase the volume, decreasing the pressure, it'd turn a darker orange. And you probably didn't quite get that possibly from the video. So it's going to go to the side with more moles of gas, which is going to be towards the right. Then if you take this equilibrium and it says that it turned a darker brown as you heated it, that means it's an endothermic because you obviously put heat over on the reactant side and shifted it right. So that's an endothermic process if it shifted it, if it turned it to a dark brown. And finally, do note that adding a catalyst or an inert gas, again, we're not going to talk about that this year, there is no shift. Don't say no change. The correct answer is no shift. When a catalyst is added, something does happen. It allows it to come to equilibrium fastest. It does speed up the forward reaction, but it does not shift the reaction left or right. Okay, so that's kind of your introduction into Le Chatelier.